We have people joining us. Awesome. Hi, everyone. Happy Saturday. I think everyone can see us now. Great. So I'm going to start sharing my screen and we'll get started over here. Okay. And here. Excellent. Everyone can see my screen? We're good? Perfect. Yep. All right, we have 36 people. That's awesome.
Hi, everyone. Welcome. Welcome to our Sea Level Solutions Day training and info session. So this is one of 3 sessions that are leading up to our Sea Level Solutions Day, which hopefully everyone's signed up for, that will occur on October 17th. So thanks everyone for joining. And Madi, if you could go to the next, oh, sorry, my name is Tiffany Troxler. I'm the Director of Science of the Sea Level Solutions Center in the Institute of Environment. And our program today is co-hosted by the Department of Journalism and Media. And we have a number of students from Dr. Jacobson's class joining us today as well. And our program is funded by the Miami-Dade Environmental Education Grant Program. So thanks everyone for joining. So we're gonna get started right away with a quality of life poll. So I think yes. Alyssa, yep, go ahead, Alyssa.
Hi everyone, so you should see a poll that popped up on your screen. This is a 6-question poll. The way that it works is you answer each of the questions, scroll all the way down and press submit. And so I'll go over the questions with you, but again, these are no right or wrong answers. Some of them are single response and others are multiple. The first question reads, I am a non-student or student. The second question, what type of business, the type of business where I work is private sector, government, nonprofit, self-employed, or I am not working. Number 3, what are the 3 most important things that determine your quality of life? Health, family and friends, happiness, freedom, learning and education, religion, being outdoors, connecting with nature, work-life balance, safety and security, good pay or job. We'll be giving you about 2 minutes to answer this. So, number 4 reads, what are the 3 most important concerns you have about sea level rise and flooding? There's a multiple response answer, so you can choose multiple answers. Applying science to make good decisions to address these issues, increasing threats from storm surge, impacts to property or property value, impacts on community, family and friends, lack of awareness and no action to address it, impacts to natural habitats and wildlife, exacerbation of social inequities, relocation, water contamination and public health impacts, and impacts to infrastructure. Number 5, what are the 3 most important concerns you have about other impacts of climate change? Increasing heat and extreme heat, more intense storms, applying science to make good decisions to address these issues, impacts to property or property value, impacts on community, family and friends, impacts to wildlife and natural habitats, impacts on public health, increasing threat from storm surge, that's on there twice, exacerbation of social inequities. And the last question, what are the 3 highest priority initiatives or actions that can be done to reduce the impacts of climate change and improve your quality of life? Increase of use of renewable energy, use bonds or small increases in taxes to reduce greenhouse gas emissions, and finance projects to reduce climate change impacts. Increase city and community initiatives that support household activities like composting, eating less meat, planting more trees. The next one is elevate buildings and other infrastructure, update codes, planning, and infrastructure based on the best available science. Increasing city or community green initiatives like tree planting, vegetable swales, vegetating swales, not vegetables, and increasing restoration of coastal habitats, supporting low wealth communities, increasing community awareness and education, and moving to lower risk neighborhoods. We're at 75%, so I'll give you just 10 more seconds to wrap up the poll, and then we'll end it, and I'll share the results. All right. Thank you for everyone that voted. I'll share the results now. Most of our attendees today are students, not working. Some of the important things that determine their quality of life: family and friends, being outdoors with nature, and work balance in life. Number 4, the most important concerns, so lack of awareness and no action to address it, impacts on wildlife and water contamination. The important concerns for other impacts of climate change are impacts to natural wildlife, natural habitats and wildlife, impact to health, and increasing heat. And the 6th question, the 3 highest priority initiatives: increasing renewable energy, more initiatives on the city and community level, and that being both green and giving them support. All right, thank you so much.
Okay, great. Thank you very much, Alyssa. All right, we're going to go into just the info session portion of our program today. And we're going to talk about sea level rise, king tides, and sea level solutions 101. So let me bring up my presentation that I just inadvertently closed. Here we go. All right, I'm going to share my screen. And I'm going to show the whole presentation, as much as I don't like it taking over my complete screen, but that's all right. So, all right, let's get started. So I'll just talk with you guys just about 10 minutes. We'll keep it short, and then we'll get into the next features of the program. So a little background. So what do we know about climate change? We know that we have seen an incredible acceleration of carbon dioxide in the atmosphere. And so you see you see a bunch of wiggly lines here along this graph. So essentially on that bottom axis, we're seeing a time frame back to 500,000 years ago. And if you look at that blue squiggly line, you see that the atmospheric carbon dioxide concentration over the last 450,000 years has never been higher than about 280 parts per million in the atmosphere. And then, whoa, lo and behold, what happened just over the last 100 years or so, we've seen an incredible increase in carbon dioxide concentrations. And each time I show this slide, I have to increase this number up here at the top. This is from January 2019. At that time, our carbon dioxide concentration in the atmosphere is measured in Hawaii was 410, got up to 410 in January 2019, and that has increased since. You can't see that increase on this figure because of the very short time frame in which carbon dioxide concentrations have increased in the atmosphere. And we know that the increase in this carbon dioxide that's in the atmosphere essentially is contributing to an increase in the warming of our atmosphere, because these types of gases are really effective at trapping heat. And when carbon dioxide concentrations go up and warming of our atmosphere goes up, we also accumulate more heat within the oceans, and that accumulation of heat and the expansion of oceans as they get warmer is one of the contributors to observed global sea level change. So this is another wiggly line figure, but I'm just going to show you here on this bottom axis here, we're showing that measured change in global sea level from about 1993, this is the gray line here, measured from satellites, to the year 2020. So that's the gray line. And then you see this blue line, which is the contribution to that change in sea level that's estimated to be mostly from glaciers and land ice. And then that red line is the contribution from the warming of oceans or the thermal expansion. And when you add those two contributors together, you get something that's tracks very closely what satellites are measuring as our change in global sea level. And so these ice sheets, Antarctic and Greenland ice sheets, both contribute to this meltwater that gets into the oceans. But that melts very slowly because these are massive volumes of ice. But the glaciers, which are smaller volumes of ice, are melting faster. So there's there's a similar contribution between glaciers, which are a lot smaller part of ice in our cryosphere, which is all of our sphere with ice and snow and things. But glaciers and ice sheets contribute about in an equivalent way. But then we also have sea level rise that is what's called relative sea level rise. And so this is what we observe in Southeast Florida. So there are different factors that contribute to the change in relative sea level that we see in Southeast Florida. And these can be associated with oceanographic factors, changes in the Earth's gravitational field to the distribution of ice melt. So if an ice mass gets smaller, then its gravitational pull changes, and that has an influence on the height of the sea near that mass of ice. And then also local uplift or subsidence. So subsidence is when the land elevation drops, and uplift is when land elevation increases. So we have some evidence of subsidence in some very localized areas in Southeast Florida, but this is not a big contributor to the change in relative sea level. But it can be very large in places like coastal Louisiana, where they see lots of land shifting downward because of oil and gas extraction, as well as the changes in the Mississippi River watershed. Okay, so let's go. So what does this mean for cities? This means that in some places, some coastal areas, low-lying coastal cities are experiencing things like sunny day flooding. So when you're in a low-lying area near a coastline, and a number of other factors can contribute to a situation that we observe called sunny day flooding. And what we have also observed is that increasing sea level contributes to a greater number of these events, and these events happening on a wider, in more places. And so this has implications for our natural and built environment. So the more wiggly lines, but these are what our local sea level rise projections look like. And this is taking a bunch of information from the federal governments, as well as the Intergovernmental Panel on Climate Change, and trying to get an understanding of what type of sea level change we might expect over a very long time horizon. And it's important to remember that the longer into the future that you're trying to project something, the less certain it becomes. So we have, here we have a little bit more, confidence about what sort of, what these different scenarios may produce in terms of how they differ from each other. And what we do with these sea level rise projections is that we use them for planning. So if you're an architect or a developer and you want to design or you want to build a building that you want to not be impacted by the potential impacts of flooding, then you would design and build your building so that it could accommodate higher levels of future sea level change. And that's an important way in which these types of curves are used. And we know South Florida is very vulnerable to sea level rise, in part because we have a very low elevation around South Florida. And also our limestone, our limestone substrate also contributes to some of the vulnerability that we experience here in terms of flooding. And here's another really fun graph. This is the rainbow graph. And this gives you an idea of what I talked about before. When sea level increases, the number of these tidal flooding events in some areas is also expected to increase. And depending on the level of that sea level change determines the number of these tidal flood events we may get. And this is an example for Norfolk, Virginia. We've developed one of these for Miami and some areas in Southeast Florida, but unfortunately it's not fully complete, so sorry I couldn't share that with you today. But what it shows you is that with the higher levels or the higher projections of sea level, you know, in terms of if we continue to emit greenhouse gases in what they call business as usual factor, where we're not aggressively using renewable energies and we're not aggressively trying to find ways to reduce the carbon dioxide emissions and the concentration of carbon dioxide in the atmosphere, that we're projected to have much more extreme changes in sea level over time. And so this graphic is showing that, for example, you know, in 2060, at this particular location, there could be a continuous flooding, you know, 365 days of flooding by 2060 if we were to not do anything to try to limit our carbon dioxide emissions. And then locally, well, in many other many other coastal areas, we have this thing called compound flooding. So it's not only about sea level rise that contributes to flooding, and it's not only about the tidal variation that we get in times like in October, where we see the highest high tides. If we have a lot of rainfall, if we have a lot of water coming down our waterways and filling up our you know, very shallow aquifer, if we have rising groundwater levels, and then we have some storm tides which are pushing water back into the inland environment, all of that adds up and can contribute to what we call compound flooding. So and when we're trying to ensure that our natural and built environment is protected from flooding, we also want to think about these other forms of flooding in addition to the sunny day flooding that we've been observing. And I wasn't sure I wanted to show this, but I'll do it very quickly. I don't know if you guys have heard of this 100-year flood. So our flood insurance is based on this idea that if you build your home above the 100-year elevation, the 100-year flood elevation, then that should reduce your risk of flooding below 1% exceedance, or 1% annual exceedance probability. But so it sounds like, you know, you're not going to get a flood in 100 years, but that's not what it is at all. It's actually, you have a 1% chance of a flood in any given year. And in the context of, let's say, your parents' 30-year mortgage, that means you have a 26% chance of a flood within that time frame that you have your house. So as these other forms of flooding contribute, that can increase the risk of flooding over time. So one really important thing is to have flood insurance. If you go home, say, or you're already at home, so say, Mom, we have flood insurance, you should consider that. So this, I don't think I have time to show this video, but one of Dr. Jacobson's students shot this video in 2017 during one of our tidal flooding citizen science flood reporting events. I think that might be me right there walking down the street. But this is sometimes we see tidal flooding like this during our I'm gonna skip through this because I think I'm running out of time. Okay, and I'm sorry, we've got a couple of, so we didn't quite get to the solutions, but Miami-Dade County has developed a sea level rise strategy, and that will be coming out soon. But it has a number of considerations of how we can use the type of data that we'll be collecting with our citizen science events to try to inform these types of strategies. Where we can use more green infrastructure, natural infrastructure, we can build on higher ground, build around transit, lots of options for adapting to sea level change. And all of that is informed by the type of information that we collect on Sea Level Solutions Day. So let's move to the next segment. Thank you.
Awesome. So Mari will be taking away our poll, and I'll start sharing my screen. Tiffany, if you don't mind stopping.
Awesome. All right, so let's get started with our second poll. We just want to see our understanding here. So hopefully you should be able to see your poll on the screen now. So the first question reads, what causes global average sea levels to rise? And this is a multiple response or multiple choice question. Therefore, you can just select all the ones that seem right to you. So the first one reads, excessive heat in the oceans caused by warming. Second option we have is melting of land ice in Greenland and Antarctica, melting of glaciers around the world, all of the above. Now the second question you should be seeing on your screen is the rate of rising sea levels in the vicinity of Miami-Dade is different from the local average, and why? Again, this is also a multiple choice question, so you can select any of the ones that you see on your screen, and you'll have a couple minutes to answer these polls. So take your time. There's 5 questions on this poll. All right, and the third question you should be seeing on your screen is flooding in coastal areas of Miami-Dade County may be caused by, is it blocked local drainage, inability of canals to discharge local flood waters, rising groundwater levels, rising sea levels, excessive rainfall, or all of the above? Fourth question is, what are the flooding threats multipliers? So is it sea level rise, increasing rainfall, rising groundwater levels, or all of the above? And the last question is, what is a 100-year flood? Also multiple choice, a flood that happens exactly every 100 years, a flood that has a 1% chance of occurrence, and a flood that can occur on an average every 100 years. All right, we're at 62%, so hopefully we get up to a 75% of voters. I see some of your answers coming in. Thank you. And I'm just going to give you 15 more seconds to answer, and we'll go ahead and take a look at the results. If at any point you have any questions for our panelists, feel free to use the Q&A feature. Here's where you can ask us any questions, and we'll be happy to answer them to you. And you can also use the chat feature if you just want to share some comments. We can look at those too. All right, so let's take a look at how do we do. Let's end this poll, and I'll share the results with you all. Okay, so what causes global average sea level rise? Yes, indeed, it's all of the above. It's excessive heat in the oceans caused by warming. It's the melting of ice in Greenland and Antarctica, and it's the melting of glaciers around the world. The second question was the rate of rising sea levels in the vicinity of Miami-Dade is different from global average, and why? And it is indeed all of the above. The redistribution of land-based ice caused by Earth gravitational field to change, changing ocean currents such as the Gulf Stream, and flooding in coastal areas of Miami-Dade may be caused by all of the above. Yes, blockage local drainage, inability of canals to discharge local floodwaters, the rising water levels, decreasing sea levels, and excessive rainfall. And our question about what are the flooding threat multipliers? Again, it's all of the above. So it's sea level rise, increasing rainfall, and rising groundwater levels. And what is the 100-year flood? A 100-year flood is a flood that has a 1% chance of occurring. So I'll stop sharing this with you all, and thanks for voting.
My turn. I go again. Can you
That was the exciting part.
yeah, can you unshare so I can share?
All yours.
Thanks. All righty. So what is this Sea Level Solutions Day all about? So Dr. Jacobson, your students are going to be October 18th, right?
Yes, students who are able to participate will be on Sunday, October 18th.
Right. Okay. Thank you. So what is this about? So essentially, not doing today. Sorry, I have to update the slide. But because we usually do the info session on the same day as Sea Level Solutions Day, but not this year. So what is this all about? We're trying to improve information about where, when, and to what extent king tide, this highest high tide of the year, where this type of flooding occurs and what the quality of the water is. And of course, have fun doing it together. And hopefully I covered a couple of ways in which this helps, but it fundamentally helps us to understand or improve our understanding of how we can develop effective adaptation strategies. And then also we can do things like use that information to have a better idea of where and when flooding is going to occur, and that can be a type of early warning flood system or early flood warning system. Okay, so I'll just a quick overview. So this citizen science work, it's about, so Dr. Jacobson is going to talk to you about the Eyes on the Rise, the flood application that we use to try to help us identify areas where we may expect flooding. And then today, we're going to teach you how to locate the site where we expect the flooding to occur and to document information about that flood. And then you go to the site and collect data on flooding. And this is in the form of taking a flood height, taking the salinity of the flood, and then taking water samples so that we can better understand the quality of the flood water. And then Dr. Jacobson is going to talk to you more about the application that's used and where all of this information is uploaded, including the pictures like the ones I'm showing here. And so that information is uploaded and entered into this application by you. And then we compile and send you maps of information that you and other citizen scientists collect, or at least make that available on the MISON Miami website. And this is an example of a Google map that Dr. Jacobson made, which includes sampling locations at a citizen science flood reporting event. I believe this one was in October 2017. So this year we saw pretty high flood levels in this neighborhood that I'm showing here. This is called, we're right here near the Little River Pocket Park. And each of these different colored dots refer to different flood heights at different times of the day. So, you know, a tidal event, 1 minute there's no flooding, and 2 hours later, the streets are fully flooded. And so that's what this is capturing, is that the beginning of the tidal event, the depths may be lower, and then they increase over time over, you know, the next hour or two, and then come down again as the tidal cycle subsides. Okay, so I think I went a little too far, but so Dr. Jacobson, please go ahead.
All right, I'm going to unmute myself. So this is what I'm going to do, everybody. I'm going to show you the Eyes on the Rise app, which allows you to see which parts of South Florida may be more susceptible to flooding during the king tides. I'm also going to show you another app that we developed called the King Tide, or the Tide Calendar. And what it does is it ties into the NOAA tide tables, and it shows you where, Alyssa, I'm going to take that away from you again. I'm sorry.
I figured.
Where it shows you where, when, on what days the tides may be highest. And then I'm going to show you an example of some data that we have collected in the past. And then I'm going to turn it over to Dr. Troxler, and she will show you the Sea Level Solutions Day app that we're going to use. And I'll put up the QR code for that ahead of time. Okay, so I'm going to share my screen. And I have everything in my Safari, so I'm going to share Safari. Okay, so this is the Eyes on the Rise app, and I will show you the QR code to get here when I'm done. But I just want to show this to you. So I put this together. I worked on a team that put this together with the FIU GIS Center and in like 2015, 2014. And what it does is it allows you to enter an address. So I'm going to enter the address of the Biscayne Bay campus of FIU, which is up in northern Miami. So it's 3000 Northeast, 151st Street. And what this does is it takes you to that location and it shows you what Google Elevation calculates the elevation to be. And elevation is important because the higher your elevation, the less likely you are to see some flooding. And 8.26 feet is actually not too bad. However, sometimes context is everything. And as you can see, the Biscayne Bay campus is situated right on Biscayne Bay. And so it takes usually a minute for this map to paint. But what will happen, if I zoom out, there we go. You can see, yes, this part of the university may be at 8 feet, but the area around it is much lower. And so when we have sea level rise of up to 6 feet, it can become quite inundated. And so I'm going to zoom out just so you can appreciate. This map is kind of a basic interactive sea level rise viewer. It takes some basic information about elevation and topography and calculates what different levels of sea level rise might look like. And when we developed this in 2014, it was like one of the first things of its kind that had ever been seen in South Florida. And so it introduced a lot of our residents to the concept of sea level rise and what it could potentially mean for their neighborhoods. All right, so we use this to help find areas that are potentially flooding when we go out to do king tide measurements. The other thing that we use is the high tide calendar. And again, I'm going to show you a QR code that has this address on it. And this operates by a similar principle. You enter your address. So I'm going to enter the address of the BBC campus, which is 3000 Northeast, 151st Street. And what it does, it pulls data from the NOAA tide tables, and it matches your location that you enter here with the closest tide monitoring station. In this case, it's Haulover Inside. So not everybody is going to have an issue with this. Not everybody's going to have an issue with flooding during the king tides, but for those of you who do, this application can give you a heads up. So for example, if we look on October 18th, which is when some of my students are going to go sampling, we can see that the high tide is at 11:27 a.m. On the 17th, it would be at 10:37 a.m. And the thing about the NOAA tide tables to remember is that they are accurate in terms of which tides are going to be higher. They're not always accurate in terms of the exact amount of tidal increase. Okay, all right. So this calendar helps us determine which days we're going to use to go out and see them. Okay, so the last thing I'm going to show you is this map This is my view. Here we go. This is the map that Dr. Troxler showed, and this has some of the data that we collected in Shorecrest just after Hurricane Irma. It was a very floody event. And so, for example, we took 3 readings, one at 10 a.m. to 11 a.m., one at 11 a.m. to 12 p.m., and one at, oh, this is a different day, sorry. So we took 2 readings, sorry. But as you can see, the earlier was lower than the later. Okay, all right. So I'm just gonna click on one of these, and this is the data that was collected by our citizen scientists. It gives us the address, the date, the context of the flood, which basically shows us where it occurred. So you can see it's quite floody. It was quite floody that day. It shows, I think this is the close-up. Yeah, so one of the things that we ask our citizen scientists to do is in the application that we're gonna show you, we ask you to measure the depth of the water using a yardstick. And to verify that information, we ask you to take a picture of the yardstick in the water. So during this time, it was quite floody. It had been just after Irma, and the entire area was saturated. Okay, I'm gonna stop sharing for a moment, and I'm going to share my PowerPoint, which has the QR codes to both of these applications. So this is the eyesontherise.org .org/app for the Sea Level Rise app. This is the high tide calendar over here. They're also available on the Meson site, which is meson.miami. Okay, so you can take a screenshot or you can use your phone to look at this. I'll give you just another couple seconds to do that, and then I'm going to go over and I'm going to put up the QR code to the Sea Level Rise app, the one that we use to document flooding on King Tide Day during the Sea Level Solutions Day. Okay.
Susan, could you post the link for that too?
Sure, in the top. Yes, okay. So do you want me to post the Eyes on the Rise or the link to the
form.
app?
Yeah, the form, yeah.
Okay. All right, so here's the form. I'm gonna post a link to it. Hang on. It's Meson, Miami. There we go. All right. Okay, I'm posting it right now to everybody in the audience. So if you, Dr. Troxler is going to talk to you about how to use this form to document the king tides on next weekend. And so you can also access it from this QR code. There's a picture of it. It's all perfectly responsive, which means you can look at it on your phone. Okay. Are you ready, Dr. Troxler?
Thank you.
Okay, I'm going to stop sharing.
All right, so, whoops. So should we go into the video now?
Sure, we can do that.
Yeah, I can.
Okay.
I can pull it up.
So this video is from a
Can
couple
everybody see? Can everybody see my screen?
Yep, yeah.
Awesome.
Wait till, give Susan a minute to introduce it before you start.
Contextualize.
Yeah,
this video is from a couple years ago. We used a different application called Fulcrum. It does basically the same thing that the Fulcrum app does than our new app, but just you'll see the screen. It looks different when they use the phone app. It's okay. It does basically the same thing. All right, I'm done.
Right.
Can you turn it up, Alyssa? Can't hear it.
No,
Nope.
Are you wearing your headphones, Alyssa?
no, ma'am.
Okay. Yeah, we can't hear it. You know what? You want me to try it on my computer?
Go ahead.
All right, everybody, give me just one moment. Okay, now I have to find the link to it again. I just put it
Here,
out.
I got it.
Paste it for me, please.
I'll send it to you quickly.
Okay.
Sorry, everyone. There's always technical difficulties.
Always technical difficulty.
Never fails.
Okay, I got it. Copy. Let me make sure I can pull it up. Yes.
Hi, my name is Brett.
Okay. All right. I'm going to share my screen. And I'm going to share my YouTube. Okay, here we go. Full screen. And I'll put on closed captions just in case.
Brad, Program Manager with the FIU Institute of Water and Environment, and I'm here to help explain in a how-to video how to use the citizen science sampling kits that we provide for king tide flooding events with the Sea Level Solutions Center. So this year's Sea Level Solutions Day is going to be November 4th, 2017, and we're going to be taking citizens out, students, teachers, residents, and FIU scientists and researchers out into local communities to conduct citizen science measurements of king tide flooding. And we're going to be distributing kits that will help provide all of the tools and information that you'll need to conduct the sampling. And we're here to explain how to do that step by step. So the first thing you're going to do is check inside your citizen science kit that we provide for an information packet on how to download the app and register, sign up for the king tide sampling. It will provide a form for you that's going to have all of the information that you're going to need to input, and it will give further instructions. And the first thing that we're going to have you do is go out in teams to different sites that we have located on a map, also inside your kit, and that's going to tell you step by step what you need to do to conduct the sampling. So each citizen science team is going to need at least 2 people, one person to conduct the actual measurements and the other to input the data into the phone through the app and take pictures throughout the process. One collecting the data. The first thing you want to do is put on your gloves. All right, so you want to have your gloves because you are going to be getting wet. You're also definitely going to want to have high boots. Rain boots, rubber boots are best because some of these events can have 2.5 feet of flooding, and so you will get wet. And that's another reason why you want the gloves, because you're going to be using your hands to actually conduct the measurement. So the first tool you're going to be using in your citizen science kit is the tape measure, and you're going to be recording the flood depth. So you're going to take your tape measure and extend it so that the 0 is facing down, and you're going to put it in the centermost part of the flood where it's deepest and record the depth in inches. And then you're also going to want to have the second person take a photo of that depth close up so that we can see where the water line is and verify that that's how deep the flood is. So the next step is to measure the salinity and see if there is any salt content in the water in the flood. You're going to take your refractometer and your pipette, which is an eyedropper. You're going to stick your pipette into the flood below the surface and squeeze so that you can draw some water in. And then you're going to flip open the lens on the refractometer and drop some of that water onto the tip, close the lens again, and then look through the eyepiece. When you look through the eyepiece, you should see a little gauge, and you're going to look on the right side for parts per thousand salinity. It should be a number somewhere between 0 and 30, 30 being salty bay water and 0 being fresh water. So look for where the dark blue line and the light blue line meet and record that number again between 0 and 30. You also want to take a picture, if you can, with your phone of the reading that the refractometer is getting, and you want to make sure that there is enough light coming through here so that you can see the actual reading in the eyepiece. When you're done, clean off the refractometer with your cloth. Next, you're going to be taking a sample of the flood with a bottle that is included in your citizen science kit. So you want to take your sampling cup and stick it upside down and put it directly into the water so the water is up to your wrist but not going above your glove, into your glove. And then you want to tilt it sideways. We don't want to collect any of the debris and stuff floating at the surface. So you want to stick it below the surface, tilt it sideways, let the bubbles come out, and then tilt it up so that you can then remove it, cap it, and put it back into your citizen science kit. Then also take a photo of the bottle with the label on it that verifies that that's the sample from that place and time. So finally, you want to make sure that you have taken enough photos of the surrounding area so that we get a sense of context. And if we go back to repeat a measurement there, we can find exactly where you sampled from and repeat that measurement and get good information. So you want to look for landmarks that will stand out, a stop sign or a lamppost. And if you can, measure how far away your sampling site was from that location. So you also want to take a close-up shot of the flood as well as a zoomed out photo to give that context and background for where you took the sample. Make sure that you have taken all of the data that the app asks for. If there are any other notes that you want to make about the location or a description of the flood, feel free to do that as well. You can take a short video, but please no more than 2 to 3 seconds if the flood is bubbling or moving, and that will help us get a sense of where it actually is. If it's located near a storm drain, these are places where we want to get information about the flood. And then finally, when you're all done, remove your gloves. And we also have included hand sanitizers so that you can clean up at the end, and then you're all set.
Okay. Let me get out of here. Stop sharing. Okay.
Okay, let's see.
Not
So-
fading.
What's that?
I said my connection keeps coming in and out, so but I'm
Oh.
here.
Great. All right, so we've set up a number of locations, and if you have already registered for Sea Level Solutions Day, you would have selected an approximate area, and then we'll be able to use that information to help you identify a location, a specific sampling site in an area that you're interested in exploring. And so Brad mentioned the refractometer. So what you see here, this is the what you see when you look into that refractometer, and he was talking about that blue-white interface that indicates the level of salinity in the water. And so that's one of the values that you'll be using the smartphone application to document. And then he also showed you the flood height instrument. We just use a regular measuring tape. And so this is an example of a photo that we ask you to take so that we can verify the information that's being uploaded into the application. And that's very important for using these information for scientific purposes. And so this map on the left here are the locations where we've sampled over the last 4 years. And so what we're trying to do is to go back to many of those locations as we have in the past, so that we can continue to build on the information database that you citizen scientists have been building over the last few years. So now I just want to go quickly into let's see, I want to stop my share. The application that Dr. Jacobson introduced to you, just so you can get a closer look at it. Can you guys see this all right? Yeah, okay,
Yes.
great. Okay, and so in a very useful way, Dr. Jacobson always has a backup plan, and that is this button right here that says instructions. Oh no, it's not set up. You're on mute?
Not yet.
Okay, not yet, but it will be. Yeah, so this is the plan B if you forget what you're supposed to do. Although we're going to provide you with that information in your kits if you need a handy, a handy reference on your phone, that's available. So you're going to be going out in groups. You're going to have a group name. We're going to ask you for the email of your group leader so that we can contact you if we have any questions. And the group leader are the station leaders. And if you were interested in being a station leader, you would have selected that when you registered for Sea Level Solutions Day. And then you can add your group members if you like. If you have, if you know what kind of phone you have, a smartphone that you're using, you can enter that information here. That's useful because it gives us a little bit more understanding of the resolution of your GPS unit so that we have an idea of how close you are when you're geotagging the location. And so also the date of the data collection, as well as the time, both really important, particularly the time to enter as you're entering this information. And then there's a nice map here. And when you go to the application for the first time, it's going to ask you, what does it say, Susan?
Allow use of location, and just say yes, say allow.
Yeah. So if you allow the use of the location when you open up the application for the first time, it's going to put this this red icon right on where you are, so that we have the geolocation of the area that you're sampling. But there's also a backup if for some reason it's not, you know, you're having trouble with it, or you're not able to drag the cursor to where your location is. You can also enter the location in the field below. And then the two primary measurements are the water depth. So you enter the number that you get from your measuring tape as well. I think it's just inches. We're collecting these data in inches. And then you want to take your friend who is who's got the smartphone and entering this information. You would like them to take a photo of as you're taking the water depth measurement, so that we can see the number on the measuring tape. And that's a photo you're going to upload into the application. Then we'd like you to as the videos illustrated, to collect the salinity, and that is measured with that refractometer. This thing here, this is the refractometer. And based on the composition of ions in the water, it uses refraction to detect the salinity of the water. And so just enter that number here. And then again, you're going to use your smartphone to put your phone, your eyepiece down the ocular and take a picture of what you see. And of course, you can't see that down in there right now because it's not facing into the light. But if you're having any trouble, just look, just make sure that you're facing the refractometer into the light, and that's how you'll be able to see, be able to take the salinity value, and then take a picture down that ocular. And then you're going to have a couple of sample bottles. One sample bottle is for a fecal indicator bacteria, so it's just a presence-absence test. And then you're going to use that same sample bottle number for a water sample that will be analyzing for nutrients and carbon content of the water. And so you'd enter your water bottle sample number here, and that will be provided to you, of course, in the kit. And then you also want to take a photo of that water bottle so that we can verify the sample number that's entered into the field. If we have, you know, if there turn out to be any discrepancies. So here you can add a description of the standing water, you take a close-up of the standing water. Then we also like a context photo, so a long shot, so you can see the environmental conditions under which we're observing this, this flood water. You can take a video of that flood water. Sometimes, you know, you can watch the flood as it's moving up onto the land and coming back, or you might see it come up through a storm drain. You might see it come over a seawall. So that's something that you can document if you choose, but a shorter video will upload faster. And then a possible contamination source. This is just, you know, if you see a trash dump nearby, or it's not saying that that's necessarily causing contamination. It's just making other observations about the environment. And then anything else you'd like to add here. And then remember, once you're all finished, hit the submit button. And Susan put a little post-it note here to remind us, because the submit button, when you hit that, that's when you get your geolocation. So if you move away from the site before you hit submit, it's going to record a different location. So before you leave the site, before you leave the location where you've taken the measurement, make sure to hit that submit button. Okay, anything that I missed, Susan? Anything you want to add? Okay.
We should have instructions maybe early next week.
What's that?
We should have instructions early next week.
Okay, instructions on the phone. Yeah, super. So we also have the times that you would have entered when you register for Sea Level Solutions Day, when you can pick up the citizen science kits. That's for the station leaders. If you're not a station leader, but you're a participant, then you just show up to the location, and that information will be provided to you as soon as we get all of our registrations in. So I guess we'd be able to do that on October 16th is when we would send that information out to everyone. Alyssa, yeah, anything else?
Not on my end, but we will be providing maps in order for you to better identify where you're going. That's given to you with your kit. So, and we're always here for any questions you guys may have. Maddie, do you want to show the registration page before we give them the satisfaction survey?
That would be great. Thank you, Liz. I'm about to share my screen and share with you all how you can register to participate on this event. So for those students who are joining us from Susan's class, you guys will be going out to BBC on October 18th. So Dr. Susan will be providing this Eventbrite link for you all to register. But again, this is only for FIU students, which is going to be October 18th. So for those who are joining us, community members, we are going to be out sampling on October 17th, right? So this is a main registration page. This is the Eventbrite. You're basically, the instructions is what we covered today, but we do ask you to please read this thoroughly. So if you do decide to register as a site leader, essentially what that means is that you feel comfortable enough to guide your team to do this samples, right? So when you go to register here, let's let it load. All right, so then you can make the decision whether you just want to participate or be a station leader. If you decide to be a station leader, you can also invite some of your friends to join, and you can get more tickets. So this should prompt a screen for me. I'm not seeing, oh, there it is. Okay, so then you register here. You'll of course put all your information, but the most important thing to take into account here is that you can select the locations that you want. So because of COVID, we do have limited capacity per location. So if you already know which location you want to sign up, we suggest the earlier the better. So these are general locations, like Alyssa said, you guys will be provided as particular location. We'll tell you exactly where to meet, but this is a general location for now. So once you choose that, then you can choose when you like to stop by BBC, FIU, the North Campus, or we can arrange something. But we have a window where you can come and pick up the sampling kits. So we have one Tuesday coming up, the 13th, from 8 a.m. to 8 a.m. to 10 a.m. And then on Friday, we have one from 3 p.m. to 6 p.m. If you click on other, if you really cannot make it during this window, let us know. We'll try to accommodate something. And so we ask you, of course, if you want to invite maybe your family and friends to join, but they couldn't attend today's webinar, then you can have them register to our upcoming webinars where we'll be going over these instructions October 15th or October 17th. And these are the links here. And again, we are always here if you guys have any questions whatsoever, and you can always attend another webinar if you want more instructions. But that pretty much covers the registration page.
Okay, so I think we're going to do the satisfaction survey, and then we're going to invite questions. So we'll stay on. We're running a little late, but we'll stay on in case you have any questions you'd like to talk through. Okay. That's it.
Awesome.
Go ahead. Who's doing
so
survey?
I'm going to launch the satisfaction survey. It's the last poll for today. There's only 3 questions, and we want to know how we did today. How would you rate today's webinar? I enjoyed it. High 5. There were some aspects I really liked, but not everything. Could have done better. Terrible. Waste of time. And you prefer not to answer. Number 2, would you like to participate in an upcoming citizen science event? Yes, no thank you, or not sure. And last, do you plan on trying to implement one of the activities you learned about today and record a report using a smartphone or other device? Yes, no, I plan to implement the activity, but I probably will not record it. So answers are coming in fast. Let's see, can we get to 80%? Oh, that was quick. All right, awesome. I'm gonna give you 5 more seconds for those last few people. Awesome. Thank you so much. I'm gonna share the results quickly. Yay, we got 88% high five. And we have many who would be interested in participating in citizen science, and they want to help record and implement these activities. Thank you, everyone.
So, how
So
do you
now
wanna-
we open,
yeah, go ahead.
I was going to say, now we open up the floor for any questions that you may have on Sea Level Solutions Day and what you'd be doing.
Someone did message us, and this is a citizen. He's 14 years old, so this is so exciting. We love young people joining us doing the sampling events. And they asked if they could leave a little bit early. So to answer your question, yes, you may. You don't have to stay all the way all the time, but we hope that you meet on time. That's the most important thing. Just arrive on time in the morning.
Yeah, but also do bring your dad, please.
Okay. What is the expected duration of the activities? How long did they take last year, more or less? How long would you say, Tiffany?
We're doing 2 samples. Are we doing 2 samples?
Yeah.
Yeah, okay, so it's 2 hours.
Okay. I hope that answers your question.
At most. It could be as little as 1 hour and 15. Because the tide, it's about 1 hour between sampling, so.
So we received another question. I'm gonna leave my email as well. So if you guys have like personal questions or like arranging needs, just email us and we'll be happy to assist there. So here's my email and we can accommodate something.
So
Oh, wait.
the question we received was for Susan's class to,
Got it.
yeah, okay, awesome. We answered it inside the Q&A feature.
Excellent. All right, well,
Do you have it?
I don't see any more questions coming in.
Let me say one thing, students, back on Zoom at 3:45 p.m.
Can I join, Susan? You're a student for a day.
All right, everyone, thank you so much. We appreciate you coming out.
Yes, indeed. All right. Well, I am good to say goodbye. Does anybody else have anything else to say? No? Okay. Well, we hope to see you there. We hope you can make it. Again, email us if you have any questions. Invite your friends and family. And do bring your parents if you are younger than 18, I suppose. All right. Take care, everyone. See you soon. Bye.
Bye.
Bye.